Kevin Martin for the Supplemental Instruction series of videos for Chemistry 121. Today we'll be discussing the strengths of acids and bases. Now, what makes a strong acid, or a strong base for that matter? Essentially, whether it's an acid or a base, if it's strong, it means it completely dissociates when it's put into solution. So in other words, with acids, the hydrogen comes off of it and it completely ionizes, and it's the same with bases except the hydroxides will break off. What makes a strong acid can be typically divided into two different areas: its size and how many oxygens it has. Now, with size, the bigger the anion is attached to the hydrogen, typically the stronger the acid will be. So example, going down the hydrohalic acids, chloride, bromide, and iodide. Hydrochloric acid is the weakest of those, followed by hydrobromic and hydroiodic, which also happens to be the order of size as it goes down the periodic table. Another determining factor for how strong an acid is how many oxygens are in a polyatomic ion. A good example of this would be with the chlorate and chlorite ions. Now, the chloric acid from the chlorate is a stronger acid than the chlorous acid from chlorite. And perchloric acid is even stronger still than chlorous acid. And as you may notice from those, chlorite is ClO2, having 2 oxygens. Chlorate is ClO3, that's 3 oxygens, and then perchlorate is ClO4, 4 oxygens. And as you may notice, as you add more oxygens to the ion, the stronger the acid becomes. Now, those